this event, and most of the sessions have had very well turnout. And while there's a lot of excitement around AI in India and in almost every dimension and in every angle, including the consumers and all, but one of the very important topics is where the artificial intelligence operates or enhances or impacts the defense ecosystem. And as much as we would have wanted to deliberate on it in the 55 minutes that we have, we would try and cover most of the grounds with the questions to the panelists. But before that, the address by the respected Deputy Chief ISNT. We are at a point of time where in the country we are trying to look at infusion of technology on so many areas, and even beyond what we are doing in the country, we are also looking at all the global linkages and the partnerships. Yesterday, the French President Emmanuel Macron was in Mumbai, and if you saw the 21 outcome statements, 5 of them were related to defense, and then of course there is one very specifically on the critical and emerging technologies and in the defense ecosystem. Same if you look at the conversations with US that has been happening, AI remains at the forefront of all the cutting edge technologies and the areas where we want to cooperate. And nevertheless, with all these efforts and what we are trying to do here, we are also trying to see that how responsively we use AI in all our activities, and that is very, very important when you look even at the defense ecosystem. So AI being a force multiplier, AI trying to improve and maybe modernize the battlefield tactics, look at the doctrines, look at how do you manage the supplies, and of course enabling the equipments to be performing much more optimally or in newer horizons. So the changing battlefield that we all see will have a significant impact with the usage of artificial intelligence and the emerging technologies. So this is where I think we have a fantastic panel. We are very lucky that this panel is confined to experts, and the number is less. Many sessions have had huge number of experts who actually cannot do justice in the time of 55 minutes that's there. With all of that, and I would like to invite the respected Deputy Chief of the Army Staff Information Systems Technology, General Shingle, to deliver the keynote address.
Thank you, sir. Thank you. Close this. Okay. Yeah, thank you. Thank you so much. And good to be here in this panel in the keynote discussion. Like I was saying just previously, that they are the experts and I am the generalist. That is why I am called a general. And one more thing, for senior officers like us, addressing gathering like this is very daunting, because normally we are addressing gathering which are uniform people, and at our by my service they are generally all junior to me, so they have no option but to firstly clap at my punchline, laugh at my jokes and so on. Here that is not a necessity. So we'll have a rule. When I give a punchline, I'll raise my left hand, so all of you clap. When I give a joke, I'll raise my right hand, then all of you laugh. Because that's the only way that I'll be able to interact. Anyway, that's on lighter vein. Let me start. Distinguished guests, the leaders, innovators from the AI community, my colleagues in uniform, some of whom are also innovators in the AI field, students, ladies and gentlemen, a very good morning to you all. It is a privilege and an honor to be addressing this important forum in this path-breaking India AI Summit, Impact AI Summit. And they are accomplished professionals who are going to be speaking about AI and its impact on warfare and conflict. So allow me to focus on a different aspect which concerns us all. That is military leadership and the responsibility of ethics regulations in AI. And what is that military leaders need to look at when they are applying AI-enabled systems in conflict. Let me begin with a brief operational moment. During a recent high-tempo military operation, a senior commander was presented with a machine-generated recommendation based on multiple sensor threats and AI analysis to engage a target immediately. The system was confident, the probability score was high, the decision window was measured in seconds. But the commander paused. Something was amiss. So he asked the question, what does the machine not know? The pause revealed something. The area that the sensors were looking at had adversary troops, but there was also a civilian evacuation underway, which had just started, which had not yet been fed into the data. It is possible that there were some troops also of the adversary with the civilian evacuation. However, the commander exercised judgment and restraint, stopped the strike, and prevented loss of innocent lives. The mission later on was completed and also won. But at that point, he exercised judgment. This brings us to a fundamental truth. AI can inform decisions, but only humans can exercise judgment and bear responsibility for them. AI is today having an unprecedented speed, scale, and efficiency. Those attributes are real and are very well understood in this room. What deserves deeper reflection is something else. The new burdens AI places on leadership, command responsibility, and strategic stability. I use the word burden with care. Autonomous and AI-enabled systems advance at extraordinary speed. Therefore, 4 questions deserve our attention. Firstly, which decisions must remain with the commanders and which decisions can be delegated to data or algorithms? No matter how accurate or efficient they become. When must human judgment, moral responsibility, and command authority remain paramount? Secondly, have our rules of engagement and safety frameworks kept pace with systems that rely on data? Do we fully understand how these systems are trained, the quality of their data, and the assumptions that they make? It is also called the black box phenomena. Today, even the creator of an AI does not know what is happening inside the black box. So you can, let alone how can commanders trust it? Thirdly, are we subjecting AI-enabled systems to the same rigor that we subject new weapon systems to? Trial evaluating them, fielding them in contested conditions, and then applying them. After all, an AI-enabled system is not a software, it's a weapon. Fourthly, are we preparing our commanders and staff to lead in a world where machines can recommend, predict, and act faster than humans without allowing speed to substitute judgment? Command and control by commanders will exercise life and death decisions. Can then be given to machines? If a machine recommends a strike with 90% accuracy and the commander takes a decision and it's the wrong decision, it gives him a moral buffer to say that it was a machine that recommended it. But is that correct? These are questions that we need to answer. It is also important to understand that these concerns are not in the military domain alone. In fact, during this summit, India has released the India AI Governance Guidelines, which is a path-breaking document on a pragmatic approach to AI governance, duly supported by a techno-legal framework. The framework identifies that since AIs are probabilistic, generative, and adaptive, they can lead to unintended consequences. These are lessons for military planners too. The second thing that the framework talks about are risks. And within that, the 6th risk is national security. One of them is, which identifies that AI facilitated disinformation campaigns, cyber attacks on critical infrastructure, and the use of lethal autonomous weapon systems as looming threats to public safety. Policymakers and defense planners need to be cognizant of these threats and also make people aware of them so that we can be resilient to them. To remain relevant, I must say, military leaders must stay on the learning curve. understand technology, both its challenges, pitfalls, and uses, while also ensuring that technology is absorbed and adopted by our units and troops. That is our responsibility. Having said that, let me be very clear that we as the Indian Armed Forces and the Indian Army are fully cognizant of the transformative power of AI to increase our operational efficiency. And we are making every effort in the direction to ensure that AI is incorporated into our decision support systems, into our surveillance, recce, and all the other functions they do. We are actively working with industry leaders, some of whom are here, startups, and academic institutions to harness AI for military applications, drawing strength from India's vibrant innovation ecosystem and our own growing band of uniformed innovators. In fact, to give push to this direction, the Indian Army has declared this year as the year of data centricity and networking, by which we are acknowledging that data is the new oil and data-centric warfare is what we need to fight. In fact, we have set up a booth in the expo as well, and I will urge all of you to go and encourage and see it and encourage our young innovators there. For India, therefore, the question is never as to whether we should adopt AI-enabled systems, but how. And we are clear that this transition must be undertaken responsibly. So what does responsible and effective approach look like? Firstly, we must institutionalize human control, not as a slogan, but as law. This requires clearly defining which functions may be assisted by AI, which may be recommended by AI, and which must always remain human decisions. Secondly, like I said earlier, AI-enabled systems need to be treated as a weapon system and be tested accordingly. Remember that the most chaotic data environment is the battlefield. An AI trained on very clear satellite images given to it in a computer lab will fail when it sees grainy, mud-soaked, smoke, deception-like images in a battlefield and can produce a wrong decision. And therefore, there needs to be the same certification, same red teaming, and same trial evaluation of AI-enabled systems. Thirdly, is about sovereignty and trust. How does a commander trust the data that is being fed into the AI-enabled system to give him the decision support? There needs to be more clarity on that. There are systems in place which are doing it, and commanders themselves must learn about it. And lastly, leadership development must evolve so that commanders who are now going to be interrogating systems, going to be not only leading troops, but also going to be, I would say, interacting with systems and taking decisions on them, should know as to what are the pitfalls, what are the challenges, and how best to use them. Moral responsibility remains with the commander. But ultimately, I would like to say that we must remember a historical truth. I personally believe in the wisdom of humanity. Whenever faced with a new crisis, we have responded well. The rules governing the use of NBC weapons, the framework that has come into place for governing landmines, the Geneva Convention itself, which talks about conduct with prisoners of war, have all stood the test of time, even in conflict. So I am confident that AI, as the new looming technology on the forefront, will also find ways and means to be regulated. In fact, as we speak, the United Nations Convention on certain conventional weapons is already on. There are many governments, many states which are part of the discussion. Consensus is complex, but it will come. India today stands at the cusp of three powerful realities. We are a major military power. We are a rapidly growing AI country or an AI ecosystem, and we are a civilization that has long understood that power must be governed by restraint. Shakti must go hand in hand with dharma or righteousness. This particular thing or particular ethos gives us both capability and credibility to lead the world in using AI responsibly in conflict. As a line from popular culture, which says that with great power comes great responsibility, I think the time has come. How wisely we carry the responsibility will shape not only future wars, but the moral leadership we choose to project. the character of war may change, our conscience cannot. With that, I would end here. I look forward to the insights by the accomplished panelists on subjects related more closely to AI and its use in conflict. Thank you and Jai Hind.
Thank you so much, sir, for bringing out many perspectives. But the most important point that you make is that the humans must be on top. AI cannot, dictate humans, and that moral responsibility of the leadership and how do you cultivate the new leadership towards that, and how the Geneva Convention has stood the test of time. I think these are very, very significant, and this gives all of us a guidance about the ethos and the direction with which you are taking the AI enablement in the Indian Army forward. Now, let me go to the panel so that we get more ideas and what they are doing in their areas, because I am left with I think about 40 minutes. So we'll try and apportion 7 minutes to each speaker, 35 minutes, and then 5 minutes we'll keep for questions. And if maybe the organizers allow, maybe we'll go a little bit more. But let me start with you, General Chibber, the DGIs. The AI disruption in military operations have already gained the grounds in terms of conversations that happen at strategic level, as well as now even in media circles also. Basically, how the integration of AI into military operations is aligned to the changing character of warfare, including ISR, cybersecurity, information operations, and decision support systems. So my first question to you would be, how can military forces effectively integrate AI-enabled ISR and decision support systems while maintaining human judgment in the OODA loop, particularly in time-compressed operational environments where the speed advantage of AI may conflict with the principles of proportionality, distinction, and command responsibility? In fact, that question flows very naturally from what the Deputy Chief just mentioned. So I would like you to respond to that, sir.
So thank you, Subimal. So as you have rightly pointed out, certain parts get answered in the opening address itself. And it's part of a global debate now, the issues which you have raised. The requirement actually is to make better decisions and not bad decisions faster. In this context, let me highlight where AI can help us make better decisions. AI can, in fact, help us to overcome what Herbert Simon calls it bounded rationality, that human beings tend to make a satisfying decision rather than an optimum or a best decision. And that is because of 4 factors. The first factor being the information is never complete when humans have to make a decision. Second is there's a cognitive limitation. If say multiple factors have to be considered, multi-criteria, human mind can easily decide between 2-factor analysis. If there are 20 factors which have to be taken into consideration for a decision, then it is challenging. Then you tend to choose only 1 or 2, factors and make your decision. That is the second limitation. Third is the time is always short. You have to take a decision in a very, quick time frame. So therefore, time to analyze all factors is not available. And fourth factor of bounded rationality is the human attention span. It is very difficult to keep attention for a very long time. All these limitations, artificial intelligence can very easily overcome. So therefore, the decision making in all the domains what you talked about can be superior to what a human would make without AI enablement. So that is the advantage of artificial intelligence. There are also some limitations. And let me highlight some limitations were highlighted by Deputy Chief in his address. There are certain limitations. When we are talking about artificial intelligence today, we are primarily talking about GPT, large language models. We are talking about generative pre-trained transformer. So as the name suggests, it is pre-trained. There's a training cycle and there's an inference cycle. There is no real-time learning which is happening. If additional learning has to take place, it has to go back to the training cycle. Whereas in a battlefield, you will have to learn as you go. There will many factors which will emerge, where you have to learn as you go. And the transformer technology itself is actually a probabilistic model of finding the next token, the next word or part of word. It is very good at that, but it fails wherever there are computational kind of algorithm to be run. So therefore, to rely on an LLM for such factors, it's better to have a hard coded program to give such kind of computation. So that is another limitation. AI also starts to fail the moment context changes. If it has been trained in one context, the moment you change the context, the result will be erroneous. That is another limitation. And the major limitation of an AI model is that it lacks abductive reasoning. Reasoning when the facts are not complete. Reasoning when the new situation has come up. That kind of decision making, if it is left to the artificial intelligence, will be disastrous. So these are the limitations. I would highlight another issue, Vimal. We normally, when we discuss this, challenge, our discussion is either in the technology domain, the reasons or the argument which I highlighted, or it goes into ethical domain, what you have said, proportionality or distinction. These two are fine. I think the discussion should also be at a deeper level, at a foundational level, at a psychological or philosophical level. How should this technology be dealt with, especially in the warfare? So in that context, let me highlight, and I'm sure those other two, that technology and ethical part is important, and there are people on the panel who are better experts than me. Let me deal this foundational aspect. Let me quote two examples. We recently had, and it has been reported in the media, that IDF used Lavender database to identify the low-level operatives in Hamas, and then they, eliminated them. And the authorization was done that if the AI engine was more than 90% accurate, you can mark that person as a target and then eliminate him. 37,000 people were identified by this AI engine and, eliminated, as per reported in open source. So if it is a 10% accepted error, there were 3,700 people who were actually innocent as per the logic itself. And if there was a collateral damage, that can be put on one side. So can we rely on that? Let me now relate it to another incident. And most of you have learned it during Vietnam War, the incident of My Lai. When a whole village was massacred in revenge, right? Ladies, children, old people, because able-bodied men would have run away, it was massacred. There was no AI engine there. So who was guiding that kind of justification or a decision making? So which is better? I think we can address it in this manner. In My Lai incident, there was a human agency, therefore attribution. William Calais could be fixed. You could put checks and balances that a no military decision is done by any person in future. You could put deterrence in a human mind because there was attributability. Whereas in case of later or the earlier example where we are using an AI engine, where is the attributability? That 10% innocent people, who can you attribute those deaths to? Is it attributable to the algorithm? Is it the person who made the database? Is it the person who wrote the code? That attributability part is missing. So if we have to deal with this technology into military domain, I think we need to address this foundational question. And that brings me to the last part of your query on the command responsibility. Who's responsible? Is it the coder? Is it the person who authorized? Is it the decision maker who laid down that 10% error is acceptable? Who's responsible? So as far as military leader is concerned, I think command responsibility can be defined in two ways. One is it involves a commander needs to have competence, that is how to do, what to do. And second is the human skill, why to do it. These two functions of command make a commander a good or a bad commander. And command responsibility in military parlance is absolute. It cannot be delegated. You cannot do your cognitive offloading to a machine. It's not expected in the present circumstances to another human being, and in a future warfare, maybe even to a machine. So one is that. Second, should we authorize lethal kind of decision or causing violence or divorce it from human agency, I don't think that would be a wise decision. AI is a tool. We need to treat it as a tool. We need to use it effectively. Any decision which affects application of lethality will remain with the human agency. So if I have to conclude, I would say that the entire proportionality, distinction and command responsibility in ethos of the Indian Armed Forces would remain with the human agency. The accountability, the responsibility cannot be delegated to even another human, let alone a machine. Thank you very much.
Thank you, sir. This was brilliant, which gives me a lot of fodder for the next question, but I'll come back to you. Let me come to Professor Ramakrishna, who has been at the forefront of building a lot of solutions and getting the forces also involved in the AI age. Now, you have been, of course, tracking the global landscape around how the whole AI ecosystem is evolving, and particularly if the AI integration in defense. So, how would you see, and what have the major military powers have been implementing AI in the command and control systems and intelligence gathering operations over the next past 3-5 years, and what specific capabilities have been demonstrated in real world conflicts or exercises? You see, the information not always is accurate, and look at our adversaries. Some people, what they do now, they bring surprises very regularly when it comes to the AI space. But even if you look with the friendly countries, there is different level. There is a skewed approach around this whole understanding and all. So what are the comparative advantages and limitations that you have observed in different national approaches to AI-centric warfare, and how do you think we are also aligning ourselves?
Thank you for that question. Alluding to what the Deputy Chief spoke in the beginning, and sir, what you emphasized, I think no command center will trust AI as a black box. I think that's key. Everyone here is on the same page there. What AI can be used for is situation summarization, pattern detection at scale. Because what machines are good at, what AI is good at, is recall. We are very good at precision, right? The domain experts are good at precision. Also, the capability to correlate across multiple sensors. Again, AI brings that big advantage. It's a force multiplier there. And finally, recommending course of action, right? Or taking cue from what Dr. Rajiv Bell, the DG ICMR, always tells me. He says that it's basically you are presenting scenarios. Here's one scenario. I mean, and that also reminds us of war games. But basically, multiple scenarios and what are recommendations. So alternatives. I think what AI can give you is alternatives, right? Technology alternatives, procedure alternatives, and present with each alternative the provenance. Now I'll use some more technical keywords here. Provenance as originated with databases, right? If you write a database query, you have the execution plan and you know why a particular result came up, right? So that provenance is very key. When I was at IBM Research before joining IIT Bombay, we were actually quite frustrated with AI over-promising and under-delivering. And we were so inspired by databases, we said, let's extend the SQL language, right? Structured query language to annotator query language. We actually created an annotator query language which uses a bit of AI, and a product was launched when I was at IBM Research. And it had its own, algebra, just like SQL has its own algebra. It was a very interesting exercise. Why? Because we can get provenance. So that's one, provenance to sources. When we met the Honorable PM on 8th Jan, a long conversation, he said, we also need attribution. So there is provenance in terms of sources, but there is attribution in terms of experts. Again, AI can, if we can get to the attribution by laying alternatives, that would be great. And third is the most technical part, which is observability stack. Right? When processes get executed. I mean, today, when training happens at Bharat Gen, we have our Deputy Director, Professor Atre, and we have this Section 8 company at IIT Bombay. called Bharatjan, where we're building models on thousands of GPUs, training models. Even inference, you'll need to ultimately delegate to a cluster of GPUs. Now, observability becomes very important. What is being delegated to CPUs, GPUs versus the network switch? Because network switch is also kind of used as a virtual memory today. That's how you're able to run computation across multiple GPUs. Observability, is there a data leakage? So having recipes, having these models as glass boxes with observability will ensure that you're running in very secure environments in air gap situations without leaving any footprint at all. So I think this attributability at every level is very important. Now the question you also brought up was specific examples of what other countries are doing. From an academic perspective, Stanford University released this very interesting open source platform called Snorkel. So, sir, you mentioned programs, right? Sometimes programs are more reliable than AI models. So what Snorkel does, it lets humans design programs, right? Complex programs. Sometimes you annotate data and you have annotator guidelines. What they say is translate all those annotator guidelines into programs. And these programs coexist with your model, can coexist with your model. Now what Stanford Snorkel did was they actually use these programs to annotate data, learn parameters of these programs. So these programs are parameterized. And then these programs are thrown away. What we realize is India, we like to always compliment. Our UPI complemented our savings economy. Can we complement what exists? So we try to differ from them. We said, well, programs are important, but programs cannot be used and through. Programs are not just to annotate data. These data programs, which you mentioned, should have the ability to override the ML model output. So we actually created an open source platform called Spear, Semi-Supervised Data Programming. My PhD student, Janvi, is also here in the audience. She worked very closely with SAMA, with the DGIS. So the idea there is our program should be able to override the models, right? Because as you pointed out, ultimately trust is a problem. And it took quite some time for the academic community to appreciate, because anything that comes from India is not necessarily viewed right, as state of the art. But finally the community accepted that this is a very good paradigm. I think we'll also have to innovate technologically to make sure that the human, the domain experts are, the command center is in the driver's wheel and not AI. I'm really enjoying this conversation. Thank you for bringing this up.
Lovely. I think you hit the nail when you said attribution, because that's possibly the biggest issue with cybersecurity for decades now, and we still don't have any solution in the horizon. Let me turn to General Anand at this stage, and look at the governance, regulation, and the policy enablement for responsible AI. I think the Deputy Chief's speech was very much clear, and both the panelists have also spoken around that. That responsibility is very, very crucial. Maybe in a civilian domain we really don't bother much about responsibility and etc. But here it has to be absolutely, the command remains with an individual and it's not delegated. So what are the regulatory approaches that defense organizations adopt to enable rapid AI deployment and development for maintaining strategic advantage while ensuring adequate testing, validation, and human oversight mechanisms are in place? And how can policy framework manage the tensions between operational urgency in military context and the precautionary principles required for high stakes AI systems? I'm sure, sir, there are a lot of precedents that we are sort of building up. So where do you see this whole landscape?
Yeah, it's a pretty complex situation, and it's probably as complex as how new technologies come in and then need to be regulated. So we've been facing it earlier on also. It's not that we haven't faced such situations. There was a very potent technology which came in terms of nuclear technology, and people were wondering how to control it. And then you did reach certain conclusions, as was mentioned by General Shingle as well. But the only change I see here is that, that was a technology which was very few people had. And AI is going to be much more democratic. So it'll be approachable by a lot of people. The second thing is the pace at which it is changing. Nuclear technology didn't change as fast. So we'll have to keep up with it. So the policies that we bring into this will have to take both these factors into consideration. Mainly, I would say that AI, with its civilian uses and as compared to what we have in the military, is characterized by 2 or 3 differences. So in our case, it's as complex perhaps as AI anywhere, but the complexity then comes in terms of the fielding of or the deployment of that technology. The second is the urgency. There are constraints of time. And the third is the risk. The risk is very high. It is lethal. It costs lives. It's not just a system going off course. So with these 3 constraints, we still have to function in the fog of war. So while there is noise and there is physicality and there is dust, there is also communication which has to take place with the machine, which can be interdicted and probably even jammed completely. So at one point it will have to go autonomous, or at one point completely human controlled by human physical means, right? So again, it gets very complex over there. But yet we have to use it in an environment where we can be sure that it is delivering results. So it has to be absolutely reliable. And that is where it becomes very different from civilian applications. It has to be absolutely reliable. If it has to kill, it has to kill. And the second thing is, we have to make sure that with all this, we still keep in mind responsibility and international human law. And international human laws will have to be adhered to, otherwise humanity is lost. So somewhere in between this, when you use a probabilistic technology, but you're getting very deterministic outcomes, there is a fundamental kind of a difference which we are bringing in here. And that's what I wanted to highlight in the first place, and the complexity comes in here. Now, how are we going to do this? I think when it comes to governance of AI, generally, we may still accept that governance lags behind how AI begins to advance faster and faster. But in the military, perhaps we can't do that. We don't have that luxury. So therefore, AI responsibility will have to be inserted at every stage of the life cycle of the development of the AI system itself in the military. And therefore, right from the ideation stage, to the design stage, to the development stage, to the deployment stage. But not only that, I would say even as you spirally develop the systems, you have to keep putting the trust factor and the re-aim, the responsible AI factor into it. And then finally, you even have to ensure that you destroy it at the right time. Because before it mutates and goes amok, you will have to make sure that it comes under control. If you've lost use of it, you have to destroy it in its completion. So at every stage of the life cycle, and that these later parts I find are completely missing from our debates. So as you go into agentic AI, I think that the later part becomes more and more important. Now, as we go from the lab into the simulation stage and into the deployment stage, what is it that I would say we should have in our phases? How do we identify each phase itself is a question mark. They are not very well defined. So you may try to define each phase, but even within that, there are various spaces which you need to ensure that you have inserted responsibility into it. The second is bias mitigation. Biases are bound to creep in. How do you keep detecting those biases? And that requires a very high amount of alertness. So while we develop a system, the responsible aspect also we need to be alert to all along. And the third aspect is safety when it comes to critical use, especially when you're talking about lethal autonomous weapon systems. Because that is where you are bringing in, the drift, which needs to be checked and kept controlled. Drift detection is very important. But I also feel that you'll have to create certain bounded envelopes under which you use your weapon systems. So those bounded operational envelopes will need to be clearly defined as to where those weapon systems will be used. And that, once defined by us, will have to be adhered to by our adversaries, and therefore we need to bring in these policy decisions. Of course, we have to have national policies, and then we'll have to start looking at the international policies. Work is happening at both ends. We need to plug them together, but there are differences in capabilities between the US and China and us. and maybe Europe? And how will we balance that out? That's the kind of discussion that we did in the REAIM summit where I just came back from at Spain. And I had suggested that our confidence building measures amongst ourselves would have to be not only tiered between the advanced powers in AI and the middle powers, but will also have to be tailored according to the requirement of each. So, and these will have to be acceptable to everyone. So I'll pause here and then go on if we get time to get
Thank
back
you,
to
sir.
it.
I sometimes rise to see what's going there so that I'm still able to come for a second question. Vikram Jayaraman, founder Neuralix, you are already working with the forces, and particularly you have a wider industry perspective at this stage, how things are happening in this country. So what mechanisms and institutional frameworks you feel are required to foster effective collaboration between the defense professional, academic researchers, technology startups, established industry players to create a vibrant AI ecosystem in the defense applications here in the country?
Thank you, first of all. I think everybody's able to hear me okay. First of all, thanks for the panel, distinguished panels, for inviting us to be here. This is one of a kind, and we are also at the inflection point of how AI is getting adopted in India, and it's a great time to be present as part of this engagement here. What I wanted to first talk about is how we are able to essentially bring these clusters together. And when I say cluster, it is the combination of deep tech startups, the nodal agencies, the military coming together, the system integrator, something that we don't pay a lot of attention to, and finally the domain experts. Sure. Not a problem. Yeah. So it is one of those things that that we have to ensure that such clusters come together, and they are moving forward in terms of developing systems that are providing what is called as an ROI. Now, ROI for defense is not profitability. ROI for defense is security. ROI for defense is getting intelligence at its faster pace. ROI for defense is building effective decision support systems. So if that has to happen, there are certain plumbing system that has to come in place. And these plumbing systems are nothing but AI models being deployed, being served. There is constant incoming of the data that we are often build these sovereign models on, and other things. Now, what is really important here is how is it that something like this comes apart? And I want to take an example of my past life as a postdoctoral researcher at MD Anderson Cancer Center. Again, very similar things. It's a question of life and death when it comes to cancer is concerned. How is it that we bring together the domain experts? There is certain policies set by the government, especially in this case, on the health side of things. Whenever we build new instrumentation, how is it that they go through what is called as basic research? Basic research goes into clinical research. Clinical research then goes applied on what is called as imaging technologies, and you try them out on small animal imaging. You take FDA approval to try it on trials on humans, and then finally it becomes a technology that moves forward. I think defense is also very similar to the medical industry, where lives matter. And when lives matter, such decisions have to be taken in this clusteral approach that the other industries have taken. So there's a lot of things that is drawn from all of these different avenues that are all there. Secondly, there has to be a form wherein the founders are now embedded within the army in terms of how We are able to understand the domain. I was, privileged enough to be born to the olive green, so I've seen this from the very beginning. But more importantly, how is it that the teams are able to understand the various nuances, the limitations also of putting such systems together, and proceeding with what is called an iterative approach. Is you build something fast enough, you test it out, you see the outcomes of it, then go back and build again. You cannot come up with something which is the greatest form of it at the very first stage itself. You've got to go back and keep iterating on it to do that. The finest models that you see today in the world, whether it is Gemini, whether it is Anthropic, whether it is ChatGPT or any of this, have gone through these phases from where they are today at this point. And then, more importantly, it is the embed of the other side also. It is the members of the armed forces should also embed themselves into the startup foundation. How do they think about it? Because as a founder, some of us have left 8-figure jobs. In US, we have left what is called as a tenured position. I was a university professor at University of Oklahoma. Left tenured jobs, and we have come here and we're doing this kind of stuff. The only way to be able to have that passion in your bone to doing innovation is when the other side also understands and have empathy for what it takes to go build technologies. And if that happens in a very bilinear in fashion, you'll see the great outcomes coming out of it. I think this is something has also been adopted very recently, although there is with DARPA in the US and how they are doing it at the same time. So this is something that is of a great monumental value of people understanding each other and how we go ahead and prolifically be able to apply technologies going further. The other area that I wanted to kind of also mention is when I come back to the plumbing system is making sure that they are effective. We test them out very quickly. I'm grateful to the IDEX program. 15, 20 years ago, something like this never existed, wherein startups could come and innovate so fast. The IDEX program has given us the opportunity to be able to come and very quickly produce something and be able to apply it to the various agencies and see what the outcomes could come out. The earlier we see the outcomes, the earlier the impact of all these technologies are happening. So in short, what I wanted to kind of conclude again is the plumbing system has to be together, making sure that we have an iterative process for testing. And Gen AI, if you look at it, is only a very small portion of the entire AI umbrella. About 15 years back, 97, when I actually came out, when I took my first grad course in UT in AI, people were laughed at it. That, you're taking neural networks. It's a theoretical subject. Nobody is even going to ask anything about it. You're not going to find a job. You're going to be jobless. And if you look at it, fast forward so many number of years now, there's not a sentence that does not start with it. But as a matter of fact, what's really important is there is a whole area of AI and data science that also needs attention at the same time. There's so many other areas wherein, especially some of my own employees, they are PhDs from UCLA, and they're data scientists. They wouldn't know D of deep learning today because they're very good at certain things of data science, and they want to make sure that the deterministic algorithms are also part of this understanding. How do we use deterministic algorithms? How do we utilize game theory concepts? How do we make sure that we are learning from data at the same time? And all of these aspects have to come together to understand it. It's not AI cannot be at the fashion of what comes in and what goes out. I think that is one thing that we have to realize, that the moment something else becomes more important, we can't be on top of that. We have to make sure that we build discipline based upon what are the outcomes of it.
So Vikram, I think this is fantastic, and this totally, takes me to what Madhumita has to speak about, because she is already into this whole seeing the military side as well as the industry, and particularly one of the areas, supply chain, that's again an area where a lot of transformation happens. But I just wanted to mention that almost the same period of time, I was a student of mathematics pursuing my post-graduation, and when I had artificial intelligence as special paper, people laughed at me. And today, it's changed so much, when the moment you looked at Python programming and looked at everything of statistics through that lens, everything has changed. Madhumita, over to you.
Are you going to ask me the question?
Mentioned about supply chain and the defense consulting, but maybe what I can tell a little bit that how are the defense organizations adapting as far as the supply chain management is concerned, deploying AI particularly from that purpose, so that the demand forecasting, inventory management, route optimization, and real-time asset tracking. I would want you to speak on that.
That was a large question. Thank you so much. And firstly, thank you everyone for having me here. Indeed, my privilege to be a part of such an august panel and such a lovely audience. To answer your question, I think globally defense supply chain is now moving from what it used to be like forecasting, stocking, and then reacting to actually sensing, predicting, and then adapting. So we have demand forecasting embedded in AI, embedded across demand forecasting, inventory routing, and all sorts of through the entire supply chain, not as a pilot but as a mission critical systems tied to readiness. Why this is important is because why it's very specific to India is because we do not have a linear supply chain. We are operating through jungles, through oceans, through really long borders, and through very many threat vectors. So how then we should be able to sustain, combat and be ready for combat is what is something that our supply chain networks have to address. So to give an example in terms of, sustained supply chain and demand forecasting that has been implemented worldwide, and because I'm a consultant, is, if you could draw from the US Defense Logistics Organization, which uses machine learning to predict spares failure, and they have a very efficient inventory management system currently at play. And the NATO as well, uses this predictive analytics to ensure that, they take into ingesting a lot of algorithms on operational tempo, terrain, and weather, and do not only rely on past data and past orders. So you see a very, very effective, inventory management system at play here, and there is something that we can learn from how they have taken this beyond. What also is very, very essential is effective warehouse and distribution, and AI has specifically played a large role here. Globally, I think we have seen, AI-driven warehouse automation in UK and US defense depots, wherein they utilize robotics, vision systems, and intelligent slotting in making sure they have an efficient warehousing automation system. We also see the Ministry of Defense in UK, wherein they have taken the onus of implementing supply chain digitization, which focuses clearly on AI-enabled demand forecasting, and of course, automated fulfillment for defense forces that are deployed. These are some of the good best practices that we can see the world over. And of course, the Russia and Ukraine war has taught us in terms of how route optimization and, how they are actually operating and showcasing resilience under fire, in which they're utilizing, AI-enabled technologies for route optimization to plan their convoys. So these are some of the, examples that I can think of. And, in closing, I'd like to say, for India specifically, I think AI in defense logistics is not about copying global markets. It's about building a resilient and indigenous system which will actually help adapt our supply chain networks to ensure that we are turning the Atmanirbhar Bharat initiative into our operational advantage.
Thank you, Madhumita. I would be unfair to the audience if I don't take your question. I know we are out of time. So just one question, if anyone has. Just give the mic. Can you come and tell loudly?
Okay. Sir, as we have seen that in the recent operations of Sindoor, we have seen that the adversary was using the AI at a large space. And we do have indigenous capabilities, but we are much, though we have developed certain softwares, but for the hardware part, we are still dependent on other countries. So, what are your perspective? How we are going ahead in building capabilities in that?
Jibber?
All right. So probably you are referring to the hardware supply chain issues, and primarily because artificial intelligence present technology relies on the GPUs, and we are reliant for imports for GPUs. So these vulnerabilities are known. They can be addressed through multiple means. One is you have multiple sources. Then is you have alternate technologies, and we are working towards that. On look, can we today develop instead of a large language model which runs on a GPU, a small language model which runs even on a CPU, and then have a large this agentic garden which small language models are running on a farm of CPUs, and then you can serve the same purpose which a GPU based large language model will give. That is another. Third is, which is related to a longer time span, is having an indigenous capability to develop this hardware. So that again, that activity is being taken up very seriously. There are 4 lead agencies which are working on producing these semiconductors within India. We lost that opportunity once in the 80s when our semiconductor limited got burned down in 1986, and we became import reliant. TSMC came up in 1987, 1 year later. Today controls 75% of the market. So we are starting late, but as I say that there is advantages of the first movers, they get a lead, but there are advantages of the last mover, you get the clarity. So we are moving in all 3 directions.
Actually, very beautifully articulated. The last more advantage can also be used to do better hardware design. For example, the new architecture, the mixture of experts, we just launched a 17 billion parameter mixture of expert with just 2 shared, mixture experts. Now the advantage is you can do very quick inference even at the level of CPUs. How can we use the workload? I think, how do you turn your software into hardware advantage? How do you turn your software workloads to design better hardware? That's an advantage you can get through the late more story.
I know a lot of hands are still there, but we are extremely short of time. I wanted to just acknowledge Mr. Pradeep Gupta, who wanted to raise a question. He has worked with EAM, RM, Finance Minister, all of them. But you are seeing all the changes that are happening. So we'll have a conversation outside, Mr. Gupta. Thank you to all of you, the Deputy Chief, sir, for giving a great context and motivating everyone to speak so well. I know we were short of time even at the start. General Chibber, so nice to hear your thoughts and how the DGIS is proceeding at pace around all of the army efforts around AI. General Anand, Vikram, Ganesh and Madhumita, I think you all have done a fantastic job. And thank you to all of you in the audience and also to the organizers for your support.
I'd like to just thank everybody.
Yes, just a second. Please be seated.
I'd like to thank everybody for being here, as also the panel. We put it together in quick time, and I think you saw that they were experts in their field, could have gone on till the evening. And I'd like to assure you, both the industry, the academia, and all the others, and of course there would be people in the industry, that we are committed to committed to ensuring that the AI ecosystem that is there in the country, whether it be startups or large players and innovators, that we incorporate them into building AI-enabled systems